Take a look at this thing. It kind of looks like a crazy steampunk chandelier, right? Well, get this. It sits inside a refrigerator that is literally colder than deep space. And it just might be one of the most important machines humanity has ever built. It's been called the most dangerous, beautiful, and revolutionary machine humanity has ever built. So, what is it? It's a quantum computer. And the reason we're talking about it right now is that it has officially left the realm of science fiction. For decades, you've probably heard this. Quantum computing was always 20 years away. It was kind of a running joke in the tech world. But this year, in 2025, that all changed. Something fundamentally shifted. We stopped asking if these machines will work. And now, the real question is, what are they going to do to us and for us? So today, we're going to break it all down. We're going to get into how this tech actually works, why this year is the big tipping point, and what our new quantum future really looks like. To really get what's going on, we have to start with the absolute basics. We're talking about the core difference between the computer or phone you're watching this on right now and a quantum computer. And it all comes down to two little words: bits and qubits. Okay, so your computer, your phone, literally everything digital you own, it runs on bits. And a bit is super simple. Just think of it like a light switch. It can be on, which is a 1, or it can be off, which is a 0. That's it. Every single photo, every email, this very video, it's just billions of these switches flicking on and off incredibly fast. But a quantum computer, it uses something totally different: a qubit. And a qubit isn't a light switch. It's more like a spinning coin. While it's in the air, before it lands, is it heads or tails? Well, it's kind of both, right? It exists in a state of both at the same time. And that both at once thing, that has a name. It's called superposition, and it is the absolute magic trick at the heart of quantum computing. It's what lets a qubit be a 1, a 0, or both, all at the same time. And that one little difference, it changes everything about how you can solve a problem. So what does that really mean in the real world? Okay, imagine you give a computer a super complex maze to solve. A classical computer, your laptop, it's going to do it the slow way. It'll try one path. Nope, dead end. Okay, back up. Try the next path. Nope, dead end again. It's methodical, sure, but it's painfully slow. A quantum computer, because of superposition, can explore every single path in that maze at the exact same time. It's like instead of setting one person in, you just flood the entire maze with water, and the water finds the exit instantly because it flows down every path at once. See, it's not just a little bit faster, it's a completely different way of thinking about the problem. Okay, so if we've known about these ideas for so long, what made this year, 2025, the year everything finally clicked? Well, it involves another quantum property, one so weird, so bizarre, that it actually baffled the great Albert Einstein himself. He literally called it spooky action at a distance. And just to be clear, he did not mean that as a compliment. He thought it was just too weird to be true. The concept he was talking about is called entanglement. And it's honestly one of the strangest and most powerful ideas in all of physics. So what is entanglement? It means you can link two qubits together so their fates are basically intertwined forever. Imagine this. You have two special entangled dice. You keep one here in New York, and you send the other one all the way to Tokyo. The second you roll your die in New York and it lands on a 6, you know instantly, with zero delay, that the die in Tokyo also landed on a 6. It's like they're communicating faster than light. They're connected, no matter how far apart they are. And this connection is what lets quantum computers perform these insanely complex, coordinated calculations. But here's the catch. For the longest time, this power was just theoretical. For decades, qubits were super, super fragile. The tiniest vibration, the slightest change in temperature, and poof, they lose their quantum state and the whole calculation would crash. This was known as the noisy era because there was just too much interference. But the huge breakthrough in 2025, it was all about error correction. Scientists finally figured out how to shield these qubits from all that noise, how to make them stable and reliable. They turned them from a delicate science experiment into an actual powerful tool. And what that means is that we've finally moved beyond just experimental toys. We're now at utility-scale machines. This is it. The era of quantum utility has officially begun. These computers can finally start solving actual, real-world problems. Okay, so you might be thinking, this is cool physics, I guess, but what does it actually mean for me? Why should I care? Great question. Let's talk about the kinds of problems these machines are actually built to solve. Honestly, the applications are kind of mind-blowing. Take medicine. Simulating how molecules interact is one of the hardest things for even our biggest supercomputers, but a quantum computer can simulate nature perfectly. We could potentially discover cures for diseases like Alzheimer's, or design cancer treatments personalized just for you. How about energy? We could design the perfect battery, electric cars that charge in minutes, phones that last for a week. Or logistics. We could optimize the traffic for an entire city in real time, basically eliminating traffic jams and slashing carbon emissions. These aren't small improvements, these are world-changing possibilities. And just to put the scale of this into perspective, let's look at discovering a new drug. Right now, with a supercomputer, that process can take decades of just brutal trial and error. With a quantum computer, we're talking about compressing that timeline down to a matter of days. That's not an upgrade, that's a revolution. So, with all this incredible promise, there's also an equally huge risk, and we have to talk about the elephant in the room. This brings us to Section 4, the race to secure everything. So, what's the dark side to all this? What happens when you take this incredible problem-solving power and you point it at the very systems that protect our entire digital world? This brings us to a, frankly, terrifying concept called Q-Day. Okay, think about it. Right now, everything, your bank account, your private messages, all of it is protected by encryption. The kind of encryption that would take the best supercomputer we have today millions of years to break. A powerful enough quantum computer, it could theoretically do it in a matter of hours. Q-Day is the name for the hypothetical moment that becomes possible, the day all our current secrets are instantly vulnerable. Now, the good news is we see this coming. This isn't a surprise attack. Experts all over the world are in a dead sprint, a race against time, to develop new types of encryption. It's called post-quantum cryptography, or PQC for short. And the goal is really simple. We have to change every digital lock on the planet before the quantum lock pickers show up. It's a huge undertaking. Okay, let's move to our final section, quantum in the cloud. So we've got this incredible potential on one hand, and this huge risk on the other. So the big question for all of us is, how is this actually going to show up in our lives? Are we going to interact with this stuff? I mean, it's a totally fair question. Are you going to have a quantum computer sitting on your desk one day, right next to your laptop? The answer to that is a hard no. Not a chance. Remember that steampunk chandelier? These machines are unbelievably delicate. They need temperatures colder than space to even work. But, and this is the important part, you will use them. Think about how you use powerful AI today. You don't have a giant server farm in your house, right? You just access it through the cloud. It's going to be the exact same thing with quantum. You'll tap into its power remotely to solve problems we used to think were literally impossible. So, here's the bottom line. The most important thing to take away from all this is that the quantum age isn't coming anymore. It's here. The utility era has begun, and honestly, it's going to be a wild ride. Which leaves us with one last question. And this one's for you. If you had access to a machine that could solve some of humanity's biggest, most complex challenges, what's the very first problem you would want it to solve? Really think about that. Thanks for joining me on this one.